take 1. Let's hope this shit works. Let's see. I need to probably erase most of everything. Okay, helping Sean with homework. Delete. Delete. Huh. I didn't get that. Shit. Delete. This should be good enough. I hope. There's some other shit here. Okay. Okay. Move this over a bit. I'm probably gonna have to upload this to YouTube because I probably won't be able to send this through Discord. Anyways, so 7 is like, I feel like I have an answer to them, but it's the fact that I got them way too easy where I'm not feeling like it's actually the answer. So I'm gonna hold off on 7. 8. A. That's an A. So really, sum of products, you're just finding all the cases where the expression is equal to 1 in the truth table. So if we look at this, so the easiest way to do this would be, starting to make the truth table. And you don't have to do this, but I just do it to show it. But I'm also going to add the x naught and y naught to make this easier. So, and then what you want to do to simplify it is you also want to break the expression down. Okay. So it's x naught plus y. I believe. So then this is, I'm not going to write the whole thing because I'm running out of space there. So, if you know how to set up a truth table, 1, 0, 1, 0, 1, 1. So the next naught is just the opposite of x, and y naught is the opposite of y. So then you just evaluate the things, which I'm assuming if there was truth tables in the questions before, you should already know how to do this. So ors, if any of them are 1, then they're automatically 1. So if y naught is 1, it's going to be a 1. And if x is 1, it's also going to be 1. So the only time it'll be 0 is if both of them are 0, which is only in this case. And same thing with the second one. So it's anytime x naught is 1, it will evaluate to 1. And anytime y is 1, it evaluates to 1 too. So the expression is just the and of both. So the and, for it to be 1, both of them have to be 1. And the only times that happens is in these two. Otherwise it's 0. Because ands are multiplication. And as you should know, if you multiply by 0, the answer is always 0. Oh, tablets are hard. Okay, let's see. There we go. So the sum of products for that one is any case where the expression is 1. So for that, the only cases are this one and this one. So it's x naught, y naught, or x, y is the only time where the expression comes out to 1. So that's the answer for that one. Let's see. So I mean, with that, you should just be able to do B and C, I hope. Because it's really just the same thing, just I mean, B and C, you'd have a C, but at that point, you just kind of X, shit, hand's too big, X, Y, Z, you're just, instead of 4, you'd have 16? Yeah. No, it's 8, I think. It's 0, 1, 0, 0, 0, 0. Yeah, 8. So it's 2, 3, 4. 1, 2, 3, 4. That's an easy way to set up truth tables if you haven't gone to this. What's that second one? X and not y plus 7. Shit. I'm getting used to this drawing tablet. So it's y naught plus z, y plus z naught. And if you did the Morgans yet, that's just x naught. I think it's x naught. Yeah, x naught times y naught. Y, you know what I meant. I'll probably cut this part out. It's really hard to use a tablet. I don't know how Dana does this shit. Okay, let's see. It's that and the fact that my fingers are just big as shit. So the pen is just tiny. Okay. Okay, so shit. Y plus Z naught. So it's like I could do Y naught times Z naught, but that's a little too much writing for me right now with this tablet. So I'm gonna just do it like this because I'm pretty good at head shit. So if we know from earlier, the only time an OR is 1 is if either one of them is 1. If any of these two are 1, then the OR is 1. But since we're negating the whole result, it'd be 0. So really what we want to get in here is 0. And the only time there's 0 is if both of them are 0. So that's only true there, there, and those are the only ones. So then the rest of them are pretty much false. And then the oppression is just ending with X. So for an and to be true, both of them have to be 1, which the only case that happens is 1 there, 1 there. So that's pen, pen, false. It's there. So all the rest of them are false. So the product of sum is just this case right here, which there's really not sum of product. Sum of product. I've been saying product of sum. Product of sum is something else. So sum of product. The only one that fits it is x, y naught, z naught. So x, y naught, z naught. And that's the only one you can really. That's the only one you can really get there. And that should help you do, what is it, 8C? See. So moving on to these logic gates. So as you should know already, that is an and. That is an or. And this is a not. Another way to write them is the symbols that y'all be using in discrete math and Boolean algebra wise, it's multiplication, addition, and the line above. Of course, sometimes they also write it as the exclamation mark in front, but that's like coding wise. Which, if we're getting coding wise, it'll be and depending. It just kind of depends on which language it is, syntax wise. But really, what you do in this problem is you just kind of follow the lines. So like that first one is an and gate, a not gate down here, and they both go into a or gate. So it's like x, y, z. So you just kind of like follow the line. So an AND gate, you would have x, y, x and y, and then the z gate when it comes, the not gate when it comes through is just z not. So you just keep following lines. So then this one is just, it's an OR gate. So you would have x, y, or z not. And that's pretty much that 9A. So then if we look at that second one, it's a not into an and into a not. So it's a not into an and into a not. drawing lines, just like X, Y. So, you just follow the line. X goes through the NOT gate. Whoa, 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 whoa. I don't know what happened there. NOT. Y goes through the NOT gate, becomes a Y NOT. It goes through the AND gate, you get X, Y, NOT, NOT. And that goes through the NOT gate. This makes it X, Y, NOT, NOT, NOT. So the reason I said be careful with this specific one was, and I wrote it down somewhere. I kind of did these beforehand, so I wouldn't know what to write when it got to it. So X, oh, wrote that shit way too high. Trying to adapt. There we go. So X, we'll write that there to make it more visible. There is equivalent to De Morgan wise X not plus Y not De Morgan's law. And then that is just equivalent to, I don't really call it De Morgan's law because it's been a while since I took it, but you just kind of like know looking at it to just split them up like that. But then if you know like that not is literally just you know it's a double negative, so that literally is just X or Y. X X. That's basically the logic gates for that one. Let's see. Was that the second? Did I do the first one? I feel like I did the first. Yeah. So I'm gonna label them. This is 9A, and this is come on, pen. 9B. So it's like if he didn't want it to be simplified, if the teacher didn't want it to be simplified, then yeah, it would just be this. But I just had a feeling, looking at that he would want it simplified, and obviously you shouldn't just write the simplified. Like you kind of have to like write why it's simplified to that, so he just kind of knows what you get. Let's see. Now the third one is difficult because I can't really see it that well. Assuming X, Y, Z, whatever that fourth one is. I'm gonna just replace that with just A, B, C, D. So it's an or into a not. It's an and into an or into a no. It's an and not or on the top. And not into an or top side, and then bottom side it's a not into an or into another or. Shit, I believe. Okay, so it's a not into one OR. Okay, so we got, how to do this, A, B, C, D. So, it's like the other one, you just kind of follow it. So it's A, A and B, and that's A, B, not, and that's A, B, not, or, so then you just go back, C, not, actually, hold on, let me check this real quick, because it could be that it's making you want to do something else here. See. X, Y, Z, X. Okay, it's an X. Okay. So ignore what I said earlier about A, B, C, D. It wants that to be an A. So C, not, or A. So then that's C, not, A. Oh, and then there's more simplification here. See if I remember how to do this. See if I remember how to do this. So that's just A not plus B not plus C plus A not plus A, because you can shift them around, plus B not plus C not A, or A not is just true, plus B not plus C not. Now, simplify wise, as soon as you get like a true there, it would just be over, because then the whole thing just equals true. Because true or anything is true. But I mean, aside from that, you could probably just want A plus B naught plus C naught. And I'm assuming that's pretty much it. What do you say? And because logic-wise, A or A naught is always going to be true. Trying to think if there's something else I have to do here. I'll pause it here real quick to see if it can pretty much just be ended as true. I'll be back in a bit. Okay, so I found like a little guide. So yeah, I wrote it as true. The guide thing really said 1, but it's pretty much the same thing. I would write 1 just to be safe. Because yeah, when that equates, basically the same thing. Now I don't know if they want you to also write down what exactly was used to get to that conclusion. If they do, then you'd kind of have to you'd kind of have to check your notes on that, because I don't know exactly what they're called. I just kind of know what they are. But yeah, that should be, those two. Okay, so I looked at a guide and apparently I was right. It really do be what I thought it was, so I can pretty much finish this out here with these two examples. Um, we have, can I copy this? Put it like down here. Please tell me. Let's go. Okay, can I make it bigger? I can make it bigger. This is hype. Okay, so yeah, it's really just as I thought it was. Easy type shit. So, 7A. So to go from logic to Boolean, fucking pin, Boolean, it's every true is 1, every false is 0, fuck, ands are multiplication, or and, no line in there. I just remember it because A, ors, or pluses, and, oh yeah, negations are just that line above the things. So if we go off of that, it's really just simple to do this shit. Let me move this over. Can I? No, of course not. Put this over here. Okay, that should be good. So the first one is TF equivalent to non-F. So like I said, each true is 1, and OR is plus 0 equals 0 not, which just simplifies to 1 plus 0 equals 1. Which, like I said, it's just hard to know if like this was actually the answer because it just seemed like way too easy to get here. But I mean, I don't know what exactly it wants you to do from here. Like, I mean, this is pretty much true. Oh, I don't know if you know this, but Boolean algebra, 1 plus 1 is equal to 1. That's like the only, that's one of the main things you gotta remember is you can pretty much add 1 to 1 and it'll always equal 1. Because anything plus 1 is 1. Let's see. But I mean that's pretty much the Boolean equality to it. I don't really know how much farther it wanted you to go off of that. So then we go to the next one. If it lets me scroll down a bit, we have not P or not Q is equal to not P and Q. So this is, which I think it said they wanted you to change P, Q, and R to X, Y, X, Y, Z. So it's X, and this will all be knotted. X or Y, not, and that's all knotted, is equal to PQ, not X, and Y. or shit. Not X and Y. Which, I mean, it's true because this pin is going to give me problems. I mean, De Morgan's, you're really going X. You know, it's just De Morgan's. Now, I don't know if it wants you to, like, say what makes it true. Like, I mean, I can write De Morgan's. De Morgan's. Shit. I believe. But yeah, and then that's times Y not, which is equal to X not times Y. Then just do that last one while I still got time here. If I can see it. P and not Q or R. P and not Q or R. Shit. So P and not Q or R. P and not Q or P and R. P not Q, P R. She. Just erase these. Q or P and R. Ow. Oh. C. So P, Q, assuming P is X, Q is Y, R is Z. So that's X and Y not or Z. It's the fact that I feel like I can't tell because that question's just worded weird. But it's like it wants me to change P, Q, and R to X, Y, Z. But it's like you could really just do it just leaving them as P, Q, and R. So I don't know why I wanted you to translate them to. At least that's what I feel like I got from that question, wording wise. So then that's X. Now I don't have to write the times. You could really just, where's Q? Y not. Like, I feel like this, I can't tell if this is just wanting you to P, C. Like, you could write it like that, or you could write it with the multiplication thing. Which, again, if you look at this, it's distributive, right? No, it's one of them. Yeah, it's distributive because it just goes Y naught plus C, and that just becomes, you know, when you distribute it, it's X Y naught plus Let's see. Distributive. Now let me see if this actually translate following equivalencies. We did that. Use Boolean variables for propositional variables. Again, I don't know why they wrote the second part of it. You could really just leave it as P, Q, and R if you wanted to, but they just wanted to get super specific on that for some reason. But I mean, let's see, I did 1, 2, 3, 2, 3, did that one. I don't feel like doing another 3 variable truth table, but you should really know how to do this. Truth tables aren't that hard. Pretty much did these 3. I mean, if you still feel like you have any trouble, just let me know. I should be back from Alan's game. I want to say like 5, like 10, minimum 10:30, depending on how late they stay over. But I'm also sending you the this PDF so you can kind of like look through my ramblings, as it were. And yeah, I'm gonna try to upload this to YouTube, depending on how it's a 30, 40-minute video. Goddamn. I accidentally pressed pause instead of stop.